Mars, our closest neighbor in the solar system, has been long speculated to harbor life-creating environment. But no life has been found yet on the red planet. Does that mean life cannot be possible on it? Well, the answer to this question is not so simple. For any planet to be able to have life on it, the first criteria is to be not very far away from its star and also not very close to its star. This region in any solar system is called the Goldilocks zone. Guess what? In our solar system, both Earth and Mars lie within this zone. But only being in this zone does not mean that a planet will have life on it. There are in fact several factors like having an atmosphere and a magnetic field, both of which are not on Mars. Yet, scientists claim to make the red planet habitable. They want to make some changes on the red planet to create Earth-like conditions through a process widely known as terraforming. You must be thinking how. Making Mars habitable for human life is a massive and complex endeavor that would require a combination of advanced technology, resources and long-term planning. Let us understand the whole idea of terraforming in our neighbor. The complex process would require a number of steps to be done, such as increasing the average temperature, generating a magnetic field, creating an atmosphere, harboring liquid water on the surface, and finally adding simple living organisms such as bacteria to finally achieve livable conditions. In theory, all these processes seem doable, but it is not so easy in practical terms. The most challenging part would be to generate a working magnetic field. But why exactly is the magnetic field so important? Well, the magnetic field protects a planet from deep space radiation, also known as the cosmic radiation. Not only this, the sun, which makes life possible on Earth, can also snatch away this very unique property. It regularly emits solar flares or solar radiation that can alter the atmosphere and make any planet unfit for living. However, the magnetic field around the Earth protects us from such conditions. So, without a magnetic field, life cannot be possible on Mars too. So, what exactly can be done to terraform our neighbor? Here are the steps to it. First, greenhouse gas emission. Mars has a very thin atmosphere composed mostly of carbon dioxide. One of the initial steps would be to increase the planet's atmospheric density by releasing greenhouse gases such as methane or other synthetic gases into the atmosphere. These gases would trap heat, thus raising the average temperature on the planet. Second, heat trapping. Giant mirrors or reflective satellites in Mars's orbit could be deployed to focus sunlight onto the planet's surface. This would actually help melt the polar ice caps and release more CO2 and water vapor into the atmosphere, further enhancing the greenhouse effect. Third, creating oxygen. Oxygen is vital for human survival, so methods to produce it on Mars would be very essential. Introducing photosynthetic organisms or genetically engineered plants would help produce oxygen through photosynthesis, just as plants do it on Earth. Fourth, nitrogen fixation. Nitrogen is another very crucial component of Earth's atmosphere. Methods to release and fix nitrogen from Martian regolith, which are basically the loose material on the planet's surface, would be necessary to create a breathable atmosphere. Fifth, creating liquid water. Liquid water is essential for life as we know it. Increasing the atmospheric pressure and temperature could allow liquid water to exist on the surface, but most of it may remain frozen. Methods to melt the ice caps and potentially bring water from other sources would be explored. Sixth, generating a magnetic field. Generating a magnetic field around Mars is a pivotal aspect of potential terraforming efforts. To protect the planet and any future human inhabitants, scientists have proposed creating an artificial magnetic shield. This shield could be established by deploying a network of large superconducting magnets at strategic locations on the planet's surface or in orbit around Mars. These powerful magnets would generate a magnetic field that envelops the planet, deflecting incoming solar wind and redirecting harmful radiation away from the atmosphere. Such a magnetic shield could contribute to building and preserving a thicker atmosphere, thereby enabling Mars to retain heat, support liquid water and offer a more hospitable environment for potential human settlement and sustained habitation. 7. Sustaining ecosystems. To support long-term human habitation, self-sustaining ecosystems within enclosed habitats would be established. These ecosystems would recycle air, water and nutrients, creating a closed-loop life support system. 8. Human adaptation. Humans may need to undergo genetic modifications or wear advanced protective gear to survive the low gravity and high radiation levels on Mars until they can adapt naturally over generations. It is essential to note that terraforming Mars is purely speculative at this point, and there are numerous challenges and potential risks associated with such a massive and unprecedented undertaking. These challenges include the availability of resources, the potential for unintended consequences, and the ethical considerations of transforming an entire planet's ecosystem. Before any attempts at terraforming Mars can be made, thorough research, planning and international cooperation would be required. As technology and our understanding of Mars improve, we may gain more insights into the feasibility and potential impacts of such an endeavour.